My name is Chaynane. I am a professor at the Faculty of Applied Sciences in Agadir. In this video, I propose you a presentation entitled Effective Parameters Extraction of Metamaterial based on Split-ring Resonators. The plan consists of 4 points that I will try to develop: problematic, retrieval, procedure, results and interpretation, conclusion. This slide illustrates two examples metamaterials. The metamaterials are emerging as promising candidates for the manufacture of radio frequency devices. These metamaterials are often periodic structures, dielectric or metallic, with a very small period in front of the excitation wavelength, and which behave as homogeneous materials, therefore can be described by so-called effective parameters such as permeability and permittivity, and do not exist in the natural state. The electromagnetic properties of these metamaterials are modified by the electromagnetic excitation of the inclusion forming these structures. In general, these two parameters give an idea of the electromagnetic characteristics of MMA unit cells. Since electromagnetic modeling and mastery of the technological processes of MMA realization are the basic elements in the manufacturing process of MMA unit cells. It is then essential to establish a general and precise model that makes it possible to predict the behavior of unit cell, whatever the shape and dimension of this structure. In this context, that we propose an approach that consists in generating analytical expression for effective permeability, effective permittivity, refractive index, and electromagnetic coupling coefficient for typical split-ring resonator cells from the transmission and reflection parameters. Figure 1 shows the schematic of split-ring resonator used to construct metamaterial. When a plane wave polarized along the z-axis is incident in the x direction, the metamaterial will show bi-anisotropic. And also the schematic of homogeneous bi-anisotropic slab placed in open space for the calculation of transmission and reflection parameters. Imposing the boundary conditions of the continuous electric and magnetic field components on the surfaces of the unit cell in the direction plus x minus x, we determine the reflection and transmission parameters as upstream and downstream of the direction of propagation. Here, z plus, z minus, n and k0 respectively the normalized wave impedances in forward plus x and backward minus x direction, the refractive index of bi-anisotropic slab, and the free space wave number. Epsilon index z is the relative complex permittivity in z direction. Mu index y is the relative permeability in y direction, and chi index 0 is the magnetoelectric coupling coefficient, a Knightley's quantity. We note that n of a bi-anisotropic slab relates not only to epsilon index z and mu index y, but also to chi index 0. Our aim here is to retrieve unique and accurate values of epsilon